All right, college algebra students, here is the other lecture video on Gaussian elimination. I just did a video on so now here's the video on Gaussian elimination. Now, what I'm going to do is cover what Gaussian elimination is, and then the examples I did in traditional elimination are going to be the same exact examples I do for Gaussian elimination. So when I go through these, the results or the answers you get as an ordered pair from the traditional examples should match up with the Gaussian. So that goes to show you it doesn't matter which method you choose. It will result in you getting the same answer regardless. So Gaussian elimination is where we will be using matrices. Okay, so I don't know if we will be able to cover or get to matrices in the spring for me to actually give a little bit more detail, but matrices are kind of like it's a structure or a setup where you are storing data and you are manipulating that data. Or you're storing numbers in a space and then you are manipulating rows, manipulating numbers, and the goal is to get, obviously in this case, the solution to this system. So what does a matrix look like? Well, it looks something like this. Sometimes you may see stuff in brackets and then there are numbers inside or letters or variables. That is a matrix. So how do we create this matrix to do Gaussian elimination? It comes from the coefficients in front of your variables and the constants. So how this matrix is going to look is I'm going to go row by row. So in the first row, your coefficients are -2, 3, and 4, and your constant is 1. So you're going to write in the first row the numbers -2, 3, 4, and 1. So that gives you the first row. In the second row, your coefficients are 3, -4, and 1, and the constant is -7. So 3, -4, 1, and -7. And then in the third row, your coefficients are 1, 2, 3, and 5. And that is a 5. That is not an S, that is a 5. All right, so now that we have created the matrix, now the goal is, well, what do we need to look for? What do we need to do? And so here is where we're going to be targeting and looking at these 3 locations. So the location that is in the first spot of the second row, first spot of the third row, and second spot of the third row. Those 3 specific locations have to be 0. So the goal is to make these equal 0. So the goal is to have those locations, the 3, the 1, and the 2, they need to be replaced with 0. How do we do it? We're going to be doing what we call row operations. So we are going to manipulate rows, we're going to manipulate values to where we can get zeros in these locations. Now the thing is, you can't do it all at once. You have to do it one at a time. Excuse me. You have to do it one at a time. But for right now, okay, we're gonna transition into creating a new matrix here. And what this matrix is going to do is going to keep row 1 and row 3 the same. I'm not going to touch anything in row 1, and I'm not going to touch anything in row 3. But now I'm going to change the values in row 2. Now, how do I do that? I will use the numbers. I will use what we call the elements or the numbers in row 1, but I'm going to use it to help me change the values in row 2. I'm going to use row 1. I'm going to be using row 1 to help me change row 2. So this is where the row operation comes into play. Let me figure out how I can manipulate values in row 1 to help me change the values in row 2. But right now, looking at row 1, the very first value in row 1 is a -2. And the very first value in row 2 is a 3. So right off the bat, I can't do something very simple as, let me just add row 1 and row 2 and that'll give me a 0. That's not going to work. But 2 and 3 have a common multiple, and that multiple is 6. How do you get 6? Well, if I take the value -2, which is resembling the value in row 1, and I multiply it by 3, 3 times -2 is -6. If I take the value that's in the first location of row 2, which is 3, and I multiply it by 2, 2 times 3 is 6. Now I have -6 and +6. How do I get 0 from that? I do -6 plus 6. So my row operation here is to take every number in row 1. I'm going to take every number one at a time in row 1, multiply it by 3, and then add it to row 2 multiplied by 2. So every number in row 1 is going to get multiplied by 3. And then every number in row 2 is going to get multiplied by 2. And then I will add them together. So the the first locations in row 1 and row 2, multiply row 1 by 3, multiply row 2 by 2, add them together. Second locations in row 1 and row 2, multiply the row 1 by 3, multiply row 2 by 2, add them together. That's what we're going to be doing. And we're changing the values in row 2. So I am focusing now on taking every number in row 1 and I'm going to multiply it by 3. I'm going to take every number in row 2, multiply it by 2, and then add them together. So -2 times 3 is -6. 3 times 2 is 6. Add them together. There is 0. 3 times 3 is 9. -4 times 2 is -8. 9 minus 8 is 1. 4 times 3 is 12. 1 times 2 is 2. 12 plus 2, 14. 1 times 3 is 3. -7 times 2, -14. 3 minus 14, -11. We have now changed row 2 to where one of the 3 locations that we need to be 0 is indeed 0. So I'm going to highlight this throughout this example that, again, we want these 3 locations to be 0. We got 1 down, we got 2 to go. All right. So now we're moving on to, and I'm going to erase this now. Now we're moving on to the second location, which is located here. I want this location here to be 0 now. So again, I'm going to use row 1, but now I'm going to change row 3. So once again, row 1 does not change. Row 2 is not going to change because I'm not using it. But now row 3 is going to change because I'm going to use the numbers in row 1 to help me change row 3. Now looking at the numbers in row 1 and row 3 in the first locations of row 1 and row 3, again, -2 here, 1 here, okay? I don't need to change -2. I'll leave it as is, but I can multiply the value 1 by 2 for row 3, and that will give me a +2. So I have -2 in row 1, and now a +2 in row 3. I just add those together, and that will give me the 0 I want. So now every element, every number in row 1, I'm going to add it to 2 times every number in row 3. So -2 plus 2 times 1, -2 plus 2 times 1, that's -2 plus 2, that's 0. 3 plus 2 times 2, that's 3 plus 4, that's 7. 4 plus 2 times 3, that's 4 plus 6, that's 10. And then 1 plus 2 times 5. 2 times 5 is 10, plus 1, that's 11. And once again, highlighting the key thing here, we now have 2 of the 3 locations are 0. So now I just have 1 more to deal with. Now here's the thing. I used row 1 to help me change row 2 and row 3 because the first locations of row 2 and row 3 needed to be 0. Once I have accomplished this, I don't use row 1 again. I now move on to row 2. What I mean these locations here and here. Now those locations need to be utilized because now the second location in row 3 needs to be 0. So I don't need to use row 1 anymore. I need to use row 2. So just shifting this over so we can have a little bit more space. So now I'm going to use row 2 to help me change row 3 again. I'm going to change row 3 one more time. Now again, row 1 does not change. Negative 2, 3, 4, 1. Row 2 will not change. 0, 1, 14, negative 11. But now I'm going to change row 3 one more time. And so what I need to do is figure out the row operation that I need to use to change row 3 with the help of row 2. So row 2 and row 3. So looking at row 2, I have 1 in the second location. And in row 3, second location, I have 7. Well, I don't need to change row 3. It's 7. I can multiply 1 by 7 to get 7. So I'll multiply row 2 by 7. And then I just subtract. 7 minus 7 is 0. So I'm going to take every number in row 2, multiply it by 7, and subtract it from every number in row 3. So 7 times 1 is 7, minus 7 is 0. 7 times 14 is 98, minus 10 is 88. 7 times negative 11 is negative 77, minus 11 is negative 88. So now I have completed getting these 3 locations to finally be 0. So now I can start solving. Answer, where are variables? Where do they come from? Okay, glad you asked. The first column relates to your x. The second column relates to y. The third column relates to z. And the fourth column relates to your constant. So for me to solve this, we're going to go bottoms up. So we're going to start in the third row, and then we'll go to the second row, and then to the first row. So how do I rewrite this third row here? It is 88z equals negative 88. 88 relates to the z variable, so it's 88z equals negative 88. And then solving for z, I get z is negative 1. I've used the third row to find z. Now we're going to move up a row, and we're now going to find y. Well, what's the equation in the second row? It is y plus 14z equals negative 11. Z is negative 1. So this gives me y plus 14 times negative 1 equals negative 11, which is just y minus 14 equals negative 11. So y is 3. And now that I have y and z, I go up one more row. And so now I find x. Well, what's this equation here? Okay, it is negative 2x plus 3y plus 4 equals 1, which is straight from the first equation of this system. So you're going to replace for y and z. Y is 3, z is negative 1, and solve for x. So that's what I'm going to do over here. So negative 2x, 3 times 3 is 9. 4 times negative 1 is negative 4. That's going to equal 1. 9 minus 4 is 5. So negative 2x plus 5 equals 1. Subtracting 5 from both sides gives you negative 2x equals negative 4. And dividing both sides by negative 2, x equals 2. So remember, you write your solution to these systems as an ordered pair. So your solution to this system is 2, 3, negative 1. And going back to the traditional elimination video, that is the answer we got when we did traditional elimination. All right, so that was the first example. And remember, I did 2 for traditional. I'm now going to do the second one for Gaussian, but you will get the same answer, okay? So just make sure that you realize that regardless of the method, you will get the same answer whether you use traditional or Gaussian. So I'm going to erase all this and put the next example on. And for this one, I'm not going to say anything. I'm just going to relate to how you set up the matrix, to do the row operations, and then your goal is to get 0 in specific locations. So this one, if you can, try to work along with me. I'm going to go as slow as I can, but just be aware that I'm not going to talk as much as I did in this first example. All right, so let's move this over here. And then we're going to zoom in just a bit, just so I can fix that up. We'll zoom out a tad, and now we are in business. Okay, so once again, we're doing Gaussian elimination. So you're going to set up your matrix. And again, coefficients and constants make up your rows. So here it is 1, 3, 4, 14, 2, negative 3, 2, 10, 3, negative 1, 1, and 9. And again, the goal is to have these 3 locations be 0. All right, so our first row operation. We don't change row 1, we don't change row 3. So 1, 3, 4, 14, and then 3, negative 1, 1, 9. But we are going to change row 2 with the help of row 1. So here is where we create our row operations. So in row 1, we have a 1 in the first location. In row 2, we have a 2 in the first location. So I am going to multiply row 1 by 2 and just subtract it from row 2, and that will give me the 0 where I need it to be. So 2 times 1 is 2, minus 2 is 0. 2 times 3 is 6, minus a negative 3 is a positive 9. Be careful with negatives. 2 times 4 is 8, minus 2 is 6. And then 2 times 14 is 28, minus 10 is 18. I've now changed the second row entirely, where the first location of row 2 is a 0. That's one of the 3 spots we need to be 0. Shrink this just a little bit so I can shift this over. Now I'm going to do row operation to change row 3 now. So row 1 stays the same. The row 1 will stay the same. So 1, 3, 4, 14. And then row 2 will stay the same. And now I'm going to change row 3. Looking at the first values for row 1 and row 3, I have 1 and I have 3. So if I want to do a row operation here, I don't need to change row 3. I just need to multiply every number in row 1 by 3 and subtract it from row 3. So 3 times 1 is 3, minus 3 is 0. 3 times 3 is 9, minus a negative 1 is a positive 10. 4 times 3 is 12, minus 1 is 11. And then 3 times 14 is 42, minus 9 is 33. All right, so now we've done row operations to get 2 of the 3 locations to be 0. And those 2 locations were right under row 1. So first location of row 1, first location for row 3. Now that I've done that, I don't use row 1 anymore. Now I'm going to use row 2. So I'm going to actually put it over here. So the row operation I'm going to use here is going to change row 3 with the help of row 2. So row 1 stays the same. Row 2 stays the same. And then the first location of row 3 will not change. But now I'm going to change the rest of row 3 using this row operation where I relate to row 2 and row 3 in the second locations respectively. Sadly here we don't have many options except to multiply row 2 by 10 and row 3 by 9. That will give us 90 for each one, so then I just subtract. So 10 times every number in row 2 minus 9 times every number in row 3 will give us what we need. So 9 times 10 is 90, minus 9 times 10 is 90, so that's 0. In fact, let me do this in a different color to show that this is changed. So there's 0. 6 times 10 is 60, minus 9 times 11, which is 99. So 60 minus 99 is a negative 39. 10 times 18 is 180. 9 times 33 is, and sadly I don't know that off the top of my head, so 33 times 9, that's 297. So 180 minus 297 is a negative 117. All right, so now we have the 3 locations we desire are now 0. So now, once again, the first column relates to x, second column relates to y, third column relates to z, last column relates to constant. So now I can start solving for my variables one at a time. So I start with z, then y, then x. So for z, I have negative 39z equals negative 117. Divide both sides by negative 39. Z is 3. I'm going to put here z is 3. Okay, so I know z is 3. I'm going to move up a row. And now I'm going to solve for y. The equation for y is 9y plus 6z equals 18. We know what z is. Z is 3. So 9y plus 6 times 3 equals 18. 6 times 3 is 18. So 9y plus 18 equals 18. Subtracting 18 from both sides, 9y equals 0. So we know y is 0. So y is 0. And then now that we know y and z, we move up one more row and we solve for x. So we have here x plus 3y plus 4z equals 14. So x plus 3 times 0 plus 4 times 3, 4 times 3 equals 14. Well, 3 times 0 is 0, 4 times 3 is 12, so x plus 12 equals 14, so I know x is 2. And now that we have the values for x, y, and z, we write it as an ordered pair, and the solution is 2, 0, 3. And that is exactly what we got when we did traditional. You can go back and check. But there you have it. There is Gaussian elimination. So either way works. You'll get the right answer as long as you are careful with your arithmetic and you take your time. If you're going to rush through it, you're going to get it wrong. Simple as that. But if you take your time, you follow the steps that I did, you follow the process, then you can't go wrong. All right, so that is it for this topic. This is all of topic 4. It is just 2 different methods, 2 different ways to solve 3x3 systems of equations by hand. So you will have a couple homework assignments related to each one. There is an going to be an ed puzzle assignment, which will have problems for you to do as you're looking through the video. So just be aware that that is going to be the homework, one of the homework assignments that you will be doing. All right. You will be getting a couple more problems to practice on, and then, of course, be prepared for your major grade activity in class. More details on that will be coming shortly. All right. Good luck to you all.